Good day everyone. In today's video, we'll be talking about the Cauchy's integral formulas. In our previous video, we talked about the complex integral and we see how we can evaluate the integral in complex plane. So in today's video, we are going to talk about the Cauchy's integral formulas. So in the Cauchy's integral formula, there are two formulas that will guide us in integrating any integral along a closed curve. And the two formula is given as f of a is equal to 1 over 2 pi I, the integral because the curve is closed, of c f of z over z minus a dz. And the second formula is fn of a equal to n factorial over 2 pi I, the integral because the curve is closed, of c f of z over z minus a raised to the power of n plus 1 dz. So these are the two formulas that will guide us in integrating any question. So the first formula there is f of a equal to 1 over 2 pi I, the integral because the curve is a closed curve. That's why we do this, of f of z over z minus a dz. And the second one is the f of n of a equal to n factorial over 2 pi I, the integral because the curve is closed, of f of z over z minus a raised to the power of n plus 1 dz. Suppose you have any question where you have z minus 2 raised to the power of 5, it means that your n is 4 because 4 plus 1 will give you 5. But if you just have any question where the denominator is just z minus 2, so you don't have to apply this formula, you just use this one. So let's take two or more examples to illustrate the Cauchy's integral formulas and see how we can use them to evaluate any integral which is analytic inside a closed curve C. Please take note, before you apply this Cauchy integral formula, the function must be analytic inside that closed curve C. And in previous video, we talked about analytic function, how a function is analytic within and on a closed curve. We said a function is analytic if the denominator is not equal to 0, and but in this case, even if our z equal to a will give us 0, but provided the singular point is interior to the curve C. So let's take this question to illustrate this form. Let's solve this question to illustrate the Cauchy's integral formulas. So the first question is evaluate the integral z square plus 2 divided by z minus 2 dz, where c is the circle, the magnitude of z minus 1 equal to 3. And second one, the integral of exponential 2z over z plus 1 to the power of 4 dz, where c is the circle, z equal to 3. And the last one there is the integral of z cubed plus z square plus sine z over z cubed dz. So please take note where c is the circle, the magnitude of z minus 1 equal to 3. Please take note, this 3 is the radius. You can watch the previous video on on how to find the loci of a function. We talk about the circle theorem. So z minus 1 is equal to 3. 3 is the radius and 1 is the center of the circle from the positive side on the x-axis, because z equal to 1 is positive. And also the second one is z equal to 3. It means the center is 0 because here is just as z minus 0. So the center is 0 and the radius is 3. So we say that for you to be able to use the Cauchy's integral formula, the singular point, we talk about singular point. We said that singular point is the point where the function fails to be analytic. And of course, the singular point here is 2 because if you put in 2 minus 2, you get 0. And z squared plus 2 divided by 0 is undefined. So it means at the point z equal to 2, this function is not analytic. So for you to be able to use the Cauchy's integral formula, the singular point must be interior to the circle. And of course, if the radius of this circle is 3 and the singular point is 2, it means that the singular point is inside the circle for this first one. And for this second one, where C is the circle, Z equal to 3, the radius is still 3. And here, the singular point is minus 1. So at the point minus 1, this function will not be analytic. And also, if this is your plane, and this is the center, and let's call here 1, 2, 3. So this will be minus 1, minus 2, and minus 3. Minus 3, minus 2, and minus 1. 1, 2, 3. And this is the center of the circle, and the radius of the circle is 3. So this is what you'll be having. 3. So if you can see, the singular point z equal to minus 1 is interior to the circle. So it means that we can still go ahead and use the Cauchy's integral formula. Then for the last one, it did not give us the radius or anything to know if this function is, if the singular point is interior to the circle. But we are going to go ahead and solve this because the singular point here is just 0. So let's see how we can solve this question. We are going to take the first one, I. The integral of z squared plus 2, the integral of z squared plus 2 over z minus 2 dz. Please take note, if you observe, the power here is 1. The power here is 1. So it means we are going to use the first formula. And the first formula is f of a equal to 1 over 2 pi I, the integral of this dz. So we are using the first formula. And the first formula there is f of a equal to 1 over 2 pi I, the integral of c, because c is closed, of f of z over z minus a dz. Compare this formula to the given integral. You see that f of z is equal to z squared plus 2, and also z minus 2, z minus a. And we said that z minus a is the same thing as z minus 2. So this implies that the singular point is z minus 2 equal to 0, so that z will be equal to 2. So the singular point there is z equal to 2 because if you put in 2 here, you get 0, and anything divided by 0 is undefined. So, and of course, the singular point is interior to our circle because the radius of our circle is 3 and the singular point is 2. And the formula there tells us f of a equals this. So let's find f of a. F of a will be equal to f of 2 because our a is 2 and this is equal to, anywhere you see the function of z, you put in 2. So we are going to have 2 squared plus 2, and this is equal to 4 plus 2, which is equal to 6. So this implies that f of a is equal to 6. So substitute everything into this formula and make this your subject of formula, because the integral from c f of z over z minus a dz is the integral they ask you to find. So we are going to have we are going to have 6 equal to 1 over 2 pi I, the integral of c f of z is z squared plus 2. Z square plus 2 over z minus a, and z minus a is z minus 2 dz. So make this subject of formula by cross multiplying. You have 12 6 times 2 pi I equals the integral of z squared plus 2 over z minus 2 dz. So therefore, the integral of c z squared plus 2 over z minus 2 dz is equal to 6 times 2 pi I to give us 12 pi I. That's the answer to that integral. So let's take the second one. Asked to evaluate this integral. So let's go ahead and evaluate this integral. If you can observe, the power here is 4. So it means we cannot use this formula. We are going to use the second one. We stated that fn of a is equal to n factorial over 2 pi I, the integral, because c is closed, of f of z over z minus a to the power of n plus 1 dz. N plus 1 dz. So this is what we have. So we are using this formula because if you take note, n here will be 3. So this can be rewritten as the integral of c exponential 2z over z plus 1 to the power of 4 dz. This can be written as the integral of f of z over z plus 1 raised to the power of 3 plus 1 dz. So this implies that n is equal to 3. N is equal to 3. And z plus 1 will be equal to 0. So z will be equal to minus 1. So minus 1 is the singular point. And we have seen that the singular point is interior to the circle. So f of z is equal to exponential 2z. So if n is equal to 3, the formula asks us to differentiate the function up to the power of n. Fn of a simply means differentiate the function up to the power of n and then put in the singular point. So we are going to differentiate this function f of z up to the power of n and the power of up to the power n, and the power n is 3. So we are differentiating this function thrice. So the first one, we have f prime of z will be equal to, if you differentiate exponential function, don't forget, you differentiate the index and multiply by the derivative of the index. So if you take the derivative of the index, you are going to have 2. Then you multiply it by the function itself, exponential 2z. So this means you are going to have 2 exponential 2z. And also, f prime prime of z will be equal to, you differentiate this again, you have 2 times the derivative of the index, which is 2 exponential 2z, and this is equal to 4 exponential 2z. Then lastly, f prime prime, which is the third derivative, will give us, differentiate the index 2, then you multiply it by the function. So we have 2 times 4 exponential 2z, and this is equal to 8 exponential 2z. And then we put in the value a, and the singular point a there is minus 1. So we have f prime 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 of minus 1 will be equal to 8 exponential 2 into minus 1. 8 exponential 2 into minus 1. So this implies we are going to have 8 exponential minus 2. 8 exponential minus. We have gotten fa of n and n factorial. So this implies that from this formula, fn of a is 8 exponential minus 2. So we have 8 exponential minus 2 equal to n factorial, but n is 3. So we have 3 factorial over 2 pi I, the integral of c f of z over z minus a, and f of z over z minus a is exponential 2z over z plus 1 to the power of 4 dz is z. So let's make this subject of formula. If we make this subject of formula, we are going to have, but first of all, what is 3 factorial? 3 factorial is 3 times 2 times 1, which is equal to 6. So 3 factorial is 6. So this means that we are going to have 8 exponential minus 2, 8 exponential minus 2 equal to 6 over 2 pi I, the integral of exponential 2z over z plus 1 to the power of 4 dz. So this will go, we have 3 here. So this implies that 8 exponential minus 2 is equal to 6 divided by 2 is 3. 3 over pi I exponential 2z over z plus 1 to the power of 4 dz. To make the subject of formula, you are going to have the integral of c exponential 2z over z plus 1 to the power of 4 dz will then be equal to 8 exponential minus 2 times pi I multiplied by 1 over 3. 1 over 3. So therefore, the integral of c exponential 2z over z plus 1 to the power of 4 dz is equal to 8 over 3 exponential minus 2 pi I. So that is what we have. All right, let's consider the third question. I. The integral of z cubed plus z squared plus sine z over z cubed dz. So also notice that the power of z here is 3. So we are still going to use the formula fn of a equal to n factorial over pi I over 2 pi I, the integral of c, because the curve is closed, f of z over z minus a to the power of n plus 1 to the power of n plus 1 dz. So we are still also going to use this formula. So first of all, identify n. N is equal to 2. From here, n is equal to 2, and f of z is equal to z cubed plus z square plus sine z. Z cubed plus z square plus sine z. So let's differentiate this. We have f prime of z will be equal to, if you differentiate z cubed, you have 3z square plus 2z. If you differentiate sine z, you have cos z. Also, f prime prime of z, differentiate 3z square, you have 6z plus, if you differentiate 2z, you have 2. differentiate cos z, you have minus sine z. So f prime prime of a, what is a? Remember, z minus a is equal to 0. So z is equal to a. And from here we have z equal to a here is 0 because there's no point there. So z is equal to 0. So we put in 0 here. We have f prime prime of 0. And this is equal to 6 into 0 plus 2 minus sine 0. And this is equal to 0 plus 2. Of course, sine 0 is 0 minus 0. So f prime prime of 0 is equal to 2. So we can continue. So let's substitute this into our formula. So we have fn of a is 2. So we have 2 equal to n factorial. Well, n is 2. 2 factorial over 2 pi I, the integral of c, because the curve is closed, f of z is z cubed plus z squared plus sine z over z minus a to the power of n plus 1, which is z cubed dz. So obviously 2 factorial is 2 because 2 factorial is 2 times 1, which is equal to 2. So we have 2 factorial to equal to 2. 2 equal to 2 over 2 pi I, the integral, the curve is closed, of z cubed plus z squared plus sine z over z cubed dz. So obviously 2 will cancel out. So we are having 2 equal to 1 over pi I, 1 over 1 over pi I, the integral, the curve is closed, of z cubed plus z squared plus sine z over z cubed dz. So this is what we have. So let's cross multiply. We have 2 times pi I will be equal to the integral, the curve is closed, of z cubed plus z squared plus sine z over z cubed dz. So therefore, it means that our integral from c of z cubed plus z squared plus sine z over z cubed is equal to 2 times pi I will give us 2 pi I. So that's the answer to that integral. Please, if you enjoyed this video, do well to subscribe. So thank you very much for watching this